Hello everyone, this is Jason. I'm going to help you with the sum or difference of cubes. So we're going to look at a couple of examples here. I want to show you how to use the pattern for the sum of difference of cubes to kind of factor these problems out. Now these are going to be the simpler problems. I'm going to give you a separate video for the ones where you have to do a little extra work. So really there's two patterns here. You have a minus b and then a squared plus ab and then always positive b squared. And then you have this pattern, a plus b, a squared minus ab plus b squared. Now, how do you know which one? We're going to use this little mnemonic device to help us figure it out. It's called SOAP. It means same, opposite, always positive. And so basically, since I have like for this example right here, I have a subtraction sign right there. So same will have a subtraction sign. So I know I'm using this pattern for this problem. If that was a plus sign, I would then use this pattern. So that's how you pick the patterns out. Let's get rid of this. We'll rewrite that as a subtraction, because we're going to do subtraction on this one. And just remember, that's how you figure out the patterns. So now how do you find A and B? Well, A and B are real simple. We're going to find the cube root of A. This is A cubed and this is B cubed. We're going to find the cube root of those things. So for this first one, the cube root of x cubed is x. And then the cube root of 125 is 5. So those are my two A and B, my cube roots. And now I'm just going to use my pattern to fill it in, and that's going to be my final answer. So these are real simple. So A minus B. So here I have x minus 5. And now I fill in, I've got x squared plus A times B plus B squared, so 5 squared. And now make sure you simplify anything that can be simplified here. So here I'm just going to have x minus 5. And the only thing I can simplify here is make that 5x and then make this 25, make it what it is. And so that's factored completely. Okay, sometimes you're given one like this where, well, 3 is not a perfect cube and neither is 375, but we can make them. And actually, I'm going to change this problem up a little bit so we use a different pattern. Then we're going to do the same problem. So do that, and now we have a place where we have to factor a GCF first. So the greatest common factor. So here we divide 3 out. And now these are both perfect cubes. So we'll go through the same pattern. Cube root of x cubed, cube root of 125, cube root of x cubed is x, cube root of 125 is 5. Make sure if you don't right now for these, it's easiest if you already have the perfect cubes memorized 1 through 10. That's usually about all we use is numbers 1 through 10. So if you have those memorized, that makes this a lot easier. And so since it's a plus sign here, remember my pattern, same, opposite, always positive. So a plus b, same, a squared minus opposite, ab, always positive, b squared. And so I'll just fill this in. This is a, this is b. So I have x plus 5, and I bring my common factor down. So that's going to be there. And then we have a squared, which will be x squared in this case, minus a times b, which will be x times 5, and then plus b squared, which is 5 squared. So kind of similar to the last one, just plus sign instead of subtraction sign, so you can see the different patterns. And again, we're just simplifying these things. and that's completely factored. So I hope this helps you with those first couple of summer difference of cube problems in the lesson. If you still need additional help, please let me know and I will get you some additional resources.